factor form of a quadratic equation or function. Let's say we have a function f of x is equal with a times x minus r1 times x minus r2. This is the general form how we can denote the factor form of quadratic function. Just let me r represent roots of the x-intercept. Axis of symmetry h is r1 plus r2 divided by 2, and the vertex is h and f of h. Just and let me emphasize here a signifies the vertical factor of compression or stretch. So like it is the same like we had for example in a standard form quadratic function or vertex form. So now let's illustrate with one example how we can solve this factor form. But this is the first in the standard form. Just let me convert into the factor form. To convert into the factor form, we take this c, the constant c, we factorize two factors that when I'm adding or subtracting, I can reach this minus 2. In fact, I can reach the b. How I can do it this? These are good, for example, two factors are 5 and 3, because if I'm taking minus 5 and plus 3, I can reach minus 5 plus 3 is minus 2. So now we are converting into the factor form, and y is equal with the x minus 5. So I'm taking literally x, and literally I'm taking this minus 5 here, what it is, minus 5. And then I'm taking x plus 3. And now we are in this situation. When we are in this situation, we already know from the factors we can find the x-intercepts. And x-intercept here, so I'm going with the shortcut. X-intercept is going to be equal with a 5 when I'm taking this equation and I equate it with a 0. So zero factor theorem, if I apply in here, I'm going to get x is equal with 5. And then I'm equating x plus 3 equal with 0, and x is going to be equal with minus 3. So this is a shortcut. How to get the x-intercept? This is a minus 3. And now if we want to write in the form of the points, those intersections, we know always we set y to be equal with 0 and x is equal with 5. So 0, 5 and 0, if we write in the order pair, and the other point of x-intercept is a minus 3 and 0. So I already got those two. So just because we have a 2 intercept, just let me denote this the first root and second root, the first x-intercept and second x-intercept. And now I want to find the axis of symmetry as we had before. Each is equal with we take the average of them, and as we saw previously in the previous slide, we already saw the h to find is r1 plus r2 divided by 2. Let me write everything. Root 1, which means or x-intercept 1 plus x-intercept 2, and is divided by 2. Because I have two intercepts, that's why I denoted this with index 1 and 2. And now I'm writing here 5 minus 3. I'm adding both of them. One is 5, the other is plus times minus 3 is minus 3, right? And I divide by 2. 5 minus 3 is 2. Let me write a little bit in with a longer step. 2 divided by 2, everything is equal with 1. So the axis of symmetry h is equal with 1. So we already found the axis of symmetry. Since I have here the x and y coordinates, now I'm going to plug here this is 1, and let me draw the axis of symmetry. The axis of symmetry is here. So it's going to be the line that divides the graph of the quadratic function or the parabola into symmetrical side. It's not very straight, but I'm trying to do my best. And h is equal with 1. And now we want to find the f of h, but in our case we denoted this function with a y, let's say, and let me write a y of h. And now whenever I have a x, I am going to plug the value of the h. And in this case I have x squared, so I am going to plug here 1 square. And then I have minus 2 times x, I am going to plug in minus 2 times 1. and the constant is minus 15. I will write in the way how it is minus 15. I will write here minus 15. And now I'm going to calculate everything. If I'm calculating everything here, 1 squared is 1, minus 2 times 1 is minus 2, minus 2 plus 1 is minus 1, and minus 15 is minus 16. So this is minus 16. So y of h, let me write here y of h separately. When I need, I don't have difficulties to find, is equal with a minus 16. So that's what it is. And now I'm writing the vertex. The vertex now is going to be h. Let me write the whole formula. What we saw previously is f of h, but because I have a y of h, let me plug here in y of h. I think makes a better sense. And when I'm finding, the vertex is going to be equal, so h is 1, and y of h is minus 1, minus 15. So this is the, and now just let me plug in the x-intercept. X-intercept is the minus 3 is here somewhere. Let me write it with a different color, with a black color, so I think it looks better, those points. Is a minus 3, but this minus 3 here, let me write it as a point, minus 3 and 0, because x is minus 3, and whenever we find, for example, the intercepts, we set one of the 0. So when we find the x-intercept, it means that we set the y is equal to 0. So this is minus 3 and 0. But the other one is a 5, x is 5 and 0. So these are other points, 5 and 0, already I have here. And the vertex here was this is a negative 16, was is 1 and minus 16. It is, it's not 15, it is 16. So, and here is the vertex, and is a minus 1, I'm sorry, is 1 and minus 16. So we already have the vertex. And we denoted all those important points. But now we want to find the y-intercept. If we want to find the y-intercept, for example, if we are looking from the perspective of the standard quadratic equation in standard form, we already know y-intercept is equal with a c, which is minus 15. But let's try here, because we are in factor form, how we can find the y-intercept in factor form. When we find the y-intercept, it means we set x is equal to 0. And we take the factor form of the function, which is whenever we have a x, we plug in a 0. So we take this equation, 0 minus 5, 0 minus 5. And the other one factor is x plus 3, but instead of the x, I'm plugging 0 plus 3. And now, when we find the y here, is going to be equal. So 0 minus 5 is minus 5, and is minus 5, and here 0 plus 3 is 3. 3 times minus 5 is minus 15. So already we are just verifying this intercept, because we already know from the standard form we can find here. And y-intercept we can write in this form, because the x is a 0, so we set 0 here, and the y is equal to minus 15. So we write in the ordered pair this y-intercept. And let's say here is somewhere, it's not in the scale of course, and is a 0 and minus 15 is a y-intercept. And now I have all the points. I have this point of interception, y-intercept, I have vertex, x-intercept, axis of symmetry. So now we are ready to graph the parabola. So to graph the parabola here, I'm going this way. Let me go a little slowly. And I'm trying to do my best, because I'm not a great artist. And this is how it looks when we are sketching the graph. So this is the graph of the parabola. But if we want, for example, to make sure we did right, we can plug in the graphing utilities. And like in the Desmos, I graphed in the Desmos. In the Desmos, this graph how it represents. As we see here, it means the x-intercept is minus 3 and 0, 5 and 0 the other x-intercept, y-intercept is 0, minus 15, and the vertex is 1 and minus 16. And when we compare it here, we have the same values. We did exactly the same, and everything is the same. Just except there is on the scale the graph, but here is a sketching graph.